Welcome to Math with Professor V. This is video lecture for section 4.3 for business calculus on the chain rule. Now, before we go over what the chain rule is for differentiation, I want to review composition of functions because that's exactly what the chain rule pertains to. And so, as just a quick recap, if f and g are two functions, then we say the composite function or composition of g and f is the function whose values are given by g composed with f of x or g of f of x for all x that are in the domain of f such that f of x is in the domain of g. And we have a couple different ways of writing this. You've probably seen this little like open circle situation. F composed with g, that means f goes on the outside, so you'd have f composed with g of x. And then if you have it the other way around, g composed with f, then you write g of f of x. All right, and the order matters. When evaluating a composition like we're going to do in the following examples, always start on the inside, work your way out. I'll say that one more time. Start on the inside, work your way out. So here we're given two functions, f of x, which is 5x squared minus 2x, and g of x, which is 8x plus 3. So find the following. We want f of g of 2. So we're starting where? We're starting on the very inside. First, we're going to find g of 2. So g of 2 means come to g of x and substitute in 2 everywhere you see x. Okay. So that's 8 times 2 plus 3. That'll be 16 plus 3. So 19. So g of 2 is equal to 19. Now what I'm going to do is go take that 19, substitute it in for g of 2 right here. So then I can rewrite this as f of 19. I don't need to keep the brackets anymore. G of 2 got replaced with 19. Are we okay so far? Fabulous. Now I take this lovely little 19 and substitute it in for x into the other function f of x. So now we want f of 19. So I come to f of x, substitute in 19 for x. So then this is just going to be 5 times 19 squared minus 2 times 19. I have 1,767 written down, but allow me to check right now because we don't want to have a whoopsie daisy. Yes, beautiful. 1,767. Good? Okay, now let's try going the other way because the composition of two functions is not necessarily commutative, only in special cases. Okay, g of f of 2. Again, where do we start? On the very inside. Yes, very good. So we need f of 2 first. So go to f of x. Do you remember what it was? 5x squared minus 2x. So 5 times 2 squared minus 2 times 2. What's that going to be? 5 times 4, 20, minus 4, 16. So f of 2 equals 16. Now I'm going to replace f of 2 with 16. So then we need to find g of 16. See how I'm no longer writing f of 2, I'm writing 16 instead because that's what it's equal to. Then I need g of 16. You're going to come to g of x. It equals 8 times x, in this case 16 plus 3. So that's going to be 131. Good? Okay, beautiful. Let's try another one. This time, things are changing. Notice I don't have a value or a constant to substitute in for the x here. It just says f of g of x. So you still do the same thing as before. Start on the inside, work your way out. I don't have a number to plug in. So instead, I'm just going to replace g of x with how it's defined right here, 8x plus 3. So I'm going to write f of, no more g of x, I'm replacing it with 8x plus 3. How you doing? Good? Okay, now look at your function f of x, because that's the function that I'm working with, and I'm going to substitute all of this in, 8x plus 3, everywhere there's an x. Now, if this gets you a little bit dizzy, what you do is you just put an empty set of parentheses everywhere there's an x. Let me show you what I mean. You're going to write 5. Instead of x, I'm putting parentheses squared minus 2 times, and I put another set of parentheses where the x is. And then all of those x's, all of those empty parentheses get replaced with, in this case, 8x plus 3. Okay, I'll repeat it again. F of 8x plus 3 is 5 times 8x plus 3 squared minus 2 times 8x plus 3. Okay, from here we have to clean up. So follow your order of operations. I'm going to multiply this all out first. Simplify your exponents first. So we have 5 times 8x plus 3 quantity squared. That's going to be 64x squared plus 48x plus 9 minus, we can go ahead and distribute. This is 16x minus 6. And then let me distribute the 5 now throughout. So this is going to be 320x squared plus 240x plus 45 minus 16x minus 6. And then we can combine like terms, right? Look, 240x minus 16x, yes. So then for our final answer, we'll have 320x squared plus 224x plus 39. Boom. I also combined 45 minus 6. Okay, how are we doing? One more, let's try g composed with f of x, other order. So this time, instead of f of x, we're starting on the very inside. I'm going to replace it with 5x squared minus 2x. So we have now g of 5x squared minus 2x. And then you're going to go to g of x. Where is it? 8x plus 3. Where the x is, I'm just going to put an empty set of parentheses. 8 something plus 3. And what goes in those parentheses? 5x squared minus 2x. Very good. Oh, this one's going to be a lot easier to simplify. Look at this. 40x squared minus 16x plus 3. And we're done. All right, lovely. So that's just a review of composition of functions. Now we're ready to look at the chain rule, which tells us how to take the derivative of a composition of functions. So if y is a function of u, that means we could write y equals f of u, and then u is a function of x, we can say u is g of x, then we can rewrite f of u as f of g of x. And then if we want to find dy dx, that equals dy du times du dx. So you have this version of the chain rule, or perhaps the version that's a little more clear. If you're taking the derivative of f composed with g of x, first you take f prime of g of x, and then you multiply by the derivative of what's inside, g prime of x. So for this, start on the outside, work your way in. Opposite of what I said earlier when you're taking the derivative right now. So start on the outside, work your way in. And really, memorizing the formula isn't helpful. It's a process that you need to practice applying, and then it'll start coming more naturally to you. But memorizing this formula for the chain rule isn't going to be helpful when you're trying to actually work through these problems, okay? So let's just start practicing. That's the way to get good at it. In the beginning, it's going to be frustrating because you're going to have to stop and think really hard, like, what's the rule? What do I do next? How is this all coming together? And then you'll be surprised. After you've just done a good set of homework problems, it's going to come a lot more naturally. You will amaze yourself. Okay, so here we have y equals 2x cubed plus 9x to the 5th. Okay, so basically what's happening is we have a composition of functions. On the very outside, I have something being raised to the 5th, and then on the inside, I have another function. So when we do the chain rule, start on the outside, you work your way in. So dy dx, or y prime, is going to be, well, what's the derivative of something to the 5th? Well, we know the derivative. Let me write this off to the side. The derivative of x to the fifth is 5x to the fourth, yes? The only problem is I don't have plain old x here, right? We have 2x cubed plus 9x. Don't fret. It starts off the same way. You have 5, leave your blank parentheses, and then the new exponent would be to the fourth, yes? Then rewrite exactly what you have inside those parentheses. Don't touch a thing, please. So it's going to be 2x cubed plus 9x. Then I need to multiply by the derivative of the stuff inside here. So the derivative of 2x cubed plus 9x is 6x squared plus 9. So if you're matching up with the formula up above, this is your g prime of x, and this is f prime of g of x. So if you want to go define it, f of x in this case for this composition would be x to the fifth, and then g of x is what's inside 2x cubed plus 9x. But that's not necessary to do. The better you can do or apply the chain rule without having to look at the formula, the better off you're going to be, you know? Okay, from here, I would say, since we can take out a 3, right? This is 3 times 2x squared plus 3. And then this 3, let me change the color so you don't get confused. This 3 and 5 I can combine. So for my final answer, I could write dy dx equals 15 times 2x cubed plus 9x to the fourth times 2x squared plus 3. And that would be my final answer. Okay, good. That box is in the way. Let's just say goodbye to the box. Okay, we'll underline it. Let's try another. Don't worry. S of t equals 8 times the square root of 4t squared plus 7. So first things first, I would rewrite this as 8 times 4t squared plus 7 to the 1/2. No, you do not need to do the product rule because this 8 is just a constant. There's no variables here. So remember, when we differentiate and there's a constant being multiplied by our function, it just comes along for the ride. Just keep it there. So here we go. S prime of t, the 8's just hanging out. We have something raised to the 1/2 power. So how do you take the derivative of something to the 1/2 power? You bring the 1/2 down front and you subtract 1, the new exponent's negative 1/2. Inside those parentheses, copy exactly what we have. Don't change a thing. Don't change a thing. We took the derivative of the outside function, the something to the 1/2. Now, because of the chain rule, I'm going to multiply by the derivative of what's inside. So derivative of 4t squared plus 7, 8t. Very good. Very good. Okay, now let's see. Can we clean up? This is 4 times 8t. That's 32t times 4t squared plus 7 to the negative 1/2. And then why don't we rewrite that negative 1/2 in the denominator as a radical? So we can leave our final answer 32t over square root 4t squared plus 7. Beautiful. Okay. Shall we continue? Good. Whether or not you said yes, I was going to keep going. So good thing you agreed. Okay. R of t is 4t times 2t to the fifth plus 3 to the fourth. Do you see how this is different? This time I do need to do the product rule because there's a variable here. So I have a product of two functions. My first function, we'll call it 4t, and then the second function is 2t to the fifth plus 3 all to the fourth. So r prime of t, I'm going to take the derivative of 4t first. It's just 4. And then I'm going to leave 2t to the fifth plus 3 to the fourth alone. So far, so good? Okay, plus now I leave 4t alone. And then I have to take the derivative of 2t to the fifth plus 3 to the fourth. So look, on the very outside is exponent 4. So basically I have something raised to the fourth. The derivative is going to be 4. Leave your empty parentheses. Now the new exponent's going to be a 3. Inside, write what we have. 2t to the fifth plus 3. Don't touch a thing. Don't touch a thing. Now by the chain rule, I'm going to multiply by the derivative of what's inside. So derivative of 2t to the 5th plus 3, what's that going to be? Good, 10t to the 4th. Okay, all the calculus is done. We're done taking the derivative. Now we have to call in the cleanup crew. Do not start foiling out everything. You'll lose your mind and it won't get you anywhere. So what we're going to try to do is factor out the greatest common factor. I have two terms, right? Well, what do they have in common? I can take a 4 out from both. Yes, I certainly can. And then I can take out 2t to the 5th plus 3 to the 3rd power. Why only to the 3rd? Because this second term only has 3 of them. I can't take out more than what any one of them has. Okay, so this is what I'm factoring out. Then let's see what's left over. So if I've taken out 4 and 2t to the 5th cubed, I have one more left. So I have 2t to the 5th plus 3. Okay, plus, and then let's see what's left over here. So I've taken out, say this 4, I've taken all of this out. So all that remains is 4t and 10t to the 4th. What does that give me? 4t times 10t to the 4th. I'll write it like this. We can do more thinking in the next line. Uh-oh, my brain kept going. Okay. Nice. Leave everything factored on the outside. So 2t to the 5th plus 3 cubed. Now inside here, this is 2t to the 5th plus 3. I don't need the parentheses. It's just to the 1st. Plus, now this is 40t to the 5th. And then, oh, I can combine like terms inside, right? So this is 2t to the 5th plus 3 cubed. 42t to the 5th plus 3. You could leave it like that, but I'm noticing I can take a 3 out from both of these, right? 3 times, this is going to be 14t to the 5th plus 1. And then I can multiply 3 and the 4 together outside. So then we'll have 12. 2t to the 5th plus 3 cubed. And then 14t to the 5th plus 1. It's helpful when you take derivatives to try to factor and clean them up as much as possible at the end, because you'll see very soon that we're going to do something with these derivatives. We don't just take them for fun willy-nilly and then just go, look, I took a derivative. We're going to do things with them, and it's most helpful when they're completely simplified and factored especially. Okay, that's where this is heading. Okay, let's try another product rule with chain rule. Things are getting spicier, I know. Example D, we have y equals x cubed plus 2 times x squared minus 1 to the 4th. I think you guys should try pausing the video and do this one on your own, okay? Did you try it? Here we go. dy dx, or y prime, equals, so I have two functions, right? X cubed plus 2 and then x squared minus 1 to the 4th. So let's do product rule. Derivative of x cubed plus 2, 3x squared. Then I leave the other function alone. Leave it alone. Plus, now I'm going to leave x cubed plus 2 alone. Leave it alone. Now I'm going to take the derivative of the other function. On the very outside, there's exponent 4. So basically, I have something to the 4th. The derivative is going to be 4, the something cubed. What goes inside, x squared minus 1, don't touch it. And then by the chain rule, I have to multiply by the derivative of what's inside, which is 2x. Good? Okay, then the calculus is done. We're going to factor and clean up. So let's see, what can I take out? Can I take out a 3? No, there's no 3 over here. You see how there's two big terms. Okay, I can't take out a 3. Can I take out x squared? No, but you can take out an x. Okay, I'll take it. That's something. What else? Can I take out x squared minus 1? Yeah, I can take out 3 of them. That's all you can take out. Okay, so here I've taken one of these x's and I've taken 3 of these. What am I left with? I still have a 3x and x squared minus 1 to the 1st. Plus, What's left over here? I took all of these out. I took an x out. I still have a 2, a 4, and an x cubed plus 2. So that's basically 8 times x cubed plus 2. Are we all right? Beautiful. So this is x times x squared minus 1 cubed. Let's distribute everything inside. 3x cubed minus 3x plus 8x cubed plus 16. So then this is x times x squared minus 1 cubed, 11x cubed minus 3x plus 16. Woohoo! Very good. Very good. Okay, just a couple more. Did you get that last one right on your own? Okay, here we go. Y equals 1 over 3x squared minus 4 to the 5th. No, it's not time to do the quotient rule. There's no variables in the numerator, right? So we don't need to do quotient rule. What we're going to do is rewrite this first. We're going to rewrite this as 3x squared minus 4 to the negative 5th. And then now no quotient rule is necessary. So y prime, the derivative of something to the negative 5th, bring negative 5 down front, the new exponent's negative 6. Rewrite what you have inside the parentheses, don't touch a thing. Now, by the chain rule, I have to multiply by the derivative of what's inside. So derivative of 3x squared minus 4, 6x, very good. Okay. Now, cleanup's a lot easier on this one. I can just multiply together the negative 5 and the 6x. That's negative 30x. And then we have 3x squared minus 4 to the negative 6th. And then I would just put all of that to the negative 6th in the denominator, since the original problem, it didn't have any negative exponents here. So I'm like, okay, that's how they want it. Positive exponents only. Bam. Good? Okay. Now sometimes you do have to do the quotient rule with the chain rule. So that's what this very last example is for. Example F, we have x squared plus 4 over 3x squared plus 2 raised to the 4th. So here we go. Let's do it very carefully. Y prime, or dy dx. Let me get set up. It's going to take some space. So we have low d high. Low means rewrite the denominator exactly out as it is. Don't touch a thing. Then d high means multiply by the derivative of the numerator, which would be 2x plus 4. That's low d high. Minus high, so the numerator, don't touch it. D low, derivative of the bottom. So derivative of something to the 4th would be 4 something cubed. The something was 3x cubed plus 2. And then I need to multiply by the derivative of what's inside. So the derivative of 3x cubed plus 2 is just going to be 9x squared. Good? Good. So let's do recap. This is low, d high, minus this is high. All of this is d low. And then we need low, low, or square the bottom, away you go. So 3x cubed plus 2 to the 4th squared would make it to the 8th. Okay, good, good, good. Now, to clean up the numerator, we're going to factor out the GCF. So let me get rid of this so we can kind of identify what's going on. Again, can you see that there's two big terms? There's the low d high, and then there's the high d low. What do they have in common? Well, for sure I can see I can take out 3x cubed plus 2 to the 3rd only, right? Okay, so we're going to take that out. 3x cubed plus 2 to the 3rd. And then we can also take a 2 out, because this is 2 times x plus 2, and this 4 is 2 times 2. So let's take out a 2 also from everybody. So let's see what's left over. Now that I've taken out 3 of these, I only have 1 left. So I have 3x cubed plus 2 to the 1st. And then I also took this 2 out here, so I just have x plus 2 left. Minus, this is all gone. I still have x squared plus 4x, I do. Or let me do the same color I had. X squared plus 4x is there. Now this 4, I took 2 out, so there's just going to be a 2 left and a 9x squared. So that's 18x squared. Over 3x cubed plus 2 to the 8th. Okay, few lovely things can happen here. This is completely gone. I can cancel it with the 3x cubed plus 2 in the denominator. Now I only have 5 left down here. So then we've got in the numerator, let's see, 2 times, we need to FOIL all of this out, don't we? FOIL your little heart out. So this is going to be 3x to the 4th plus 6x cubed plus 2x plus 4 minus, let me put some parentheses, we're going to distribute 18x to the 4th plus 72x cubed. And then the denominator is now only 3x cubed plus 2 to the 5th. Okay. And then last step, let's combine some like terms. Keep the 2 outside. I have 3x to the 4th minus 18x to the 4th. So that's negative 15x to the 4th. 6x cubed minus 72x cubed once I distribute the negative. So that's negative 66x cubed plus 2x plus 4. That doesn't change. Over 3x cubed plus 2 to the 5th. And we are done. Woohoo! Okay. If you still feel like you'd like to see more examples, I have a few additional lecture videos. They're for pure calculus for STEM majors. So just ignore the trig functions. If there's sines and cosines and tangents and you're like, I didn't learn those derivatives. I know you're not supposed to, but you can do chain rule with exponential functions. There's some in there, and just looking at more examples I think will help you. So I'll link those videos in the description. And just keep practicing. So like I said in the beginning, when you're learning these rules, you're going to have to stop and remind yourself how to proceed over and over. But it's like any skill you learn. It's especially like learning a new language. In the beginning, you're stopping and thinking, what are the rules of conjugation? What are the grammar rules? What am I doing? And then eventually you become fluent with enough practice. Okay, so this will start flowing more. Just be patient with yourself. Don't forget to give the video a thumbs up, subscribe if you haven't already. Follow me on Instagram, TikTok, Twitter, Math with Professor V. I'll be back with more lectures sooner than later. Love you guys so much. Bye.